produces straight plane waves, while the spherical dippers produce the circular waves. And how do the plane waves look like? And how do the circular waves look like? So here I'm going to show you how these are plane waves. You've seen these straight waves here. Show you this how plane waves look like, or straight waves. Again, to show you these are straight waves. Now let's look at the circular waves. Circular waves come like that. Again, those are circular waves. Okay, so if you have placed a spherical dipper like here in water, then it produce waves like this, okay, which are circular waves. Okay, so having understood the type, the shapes of waves, circular and plane waves, so we can now look at reflection as the first property to study. Reflection of plane waves on a plane reflector. We shall going to look at how the plane waves we have seen above are reflected by a plane reflector. Okay, when you have a plane reflector like this dark part here, this is a straight reflector. When waves are incident, which are these ones, solid not dotted, acting as incident waves, they are reflected back as plane also in the plane waves. So let's look at the action. That is our reflector, and we have our plane waves. Okay, when you have our plane waves, then how are they reflected? When they come, then they are reflected. Those are incident waves. Incident waves are reflected back also as plane waves. Incident waves are reflected back as plane waves. So the dotted ones represent the reflected what? Waves. So when they are plane on a plane reflector, they are reflected back as plane waves. Okay, so we can have that. Then how about if the reflector is slanting, put at a certain angle? So if the waves are put at a certain angle, rather the reflector is put at an angle like this one here, the incident waves go, they will be reflected downwards. Okay, they will be reflected like this. Okay, we have our slanting reflector, so we have our incident waves. Okay, and you have the reflected waves. We have the incident waves, the reflected waves. Okay, let's look at the action again. Incident waves, the reflected waves. So these go in this direction. When they hit this reflector, they are reflected in this direction as straight. Okay, and you have looked at that. So that is how the waves are reflected back when the reflector is slanting, or it is at a certain angle. Now we are going to look at the reflection of straight waves on a circular barrier. We have looked at reflection of straight waves on a plane barrier, on a straight barrier. How about if it is curved, or a circular barrier? For example, this shape, which is a concave reflector. If I have something shaped in this as the reflector, how do the plane waves go? And here this diagram is showing that they will go and produce circular waves coming back, but at this point here there will be a focal point which will be acting as a source to produce other waves which have changed the shape. Okay, so that is the action. When we have the waves going to hit this, how are they reflected back? They are reflected back like that, reflected back like that. Let's repeat that action. Okay, if I have straight waves, they are reflected back like that, and then like that. Okay, I want to repeat for you. So this one is giving us that when the waves, straight waves come and they hit here, they produce circular waves which look like the shape of the concave reflector, but also on this other side there will be another shape which will change, which is that. Okay, want to give you the action again. Okay, like that. So that is how the plane waves are reflected back with a concave reflector. How about a convex reflector? How about a convex reflector? Okay, if we have a convex reflector like this one here, have a convex reflector like this one here, then the straight waves will come and then will come. If we have a concave reflector like this one here, then the straight waves will come, then be reflected back like that. Let's repeat that action. It will come and produce like that. So this action can now be seen here, that when the waves come, they are reflected back as circular waves, taking the shape of again the reflector, taking the shape, acting as if the source of the waves is at this point of the reflected waves. Okay, so that's the reflection of waves on a concave reflector. Then we look at circular waves. How are circular waves reflected on a plane reflector? How are circular waves reflected on a plane reflector? If I have a straight reflector here, like barrier like this, and I have circular waves, how are they reflected? This is the action. They come back like that. Repeat that. When they hit this barrier, they change the shape and come back like this. And we go back to the action. We have the circular waves coming, okay, and they are reflected back like this. And all this is observed in the repo tank. On the screen of the repo tank, they come and they are reflected back like that, giving us this kind of diagram if you have to draw in our book. So this produces, this is how the circular waves are reflected. Circular waves are reflected on a plane surface. So look at how circular waves on a curved barrier. How are they reflected on a curved barrier? On a concave, here on the concave reflector, they depend on the position of the source O from the barrier. Here they depend on the position of the source O. Now here, if I have the reflector, this, if I take this to be the point P, point F, point C, and point O. So if the source is beyond C, which is called the center of curvature, then the waves will move. The waves will move. When they strike here, they will come back like this, like this, like this. They will come back, and at this point there will be an image will produce again waves like that. Okay, okay. But if the source O is at F, if now we shift this source to be at this point F, then the waves, the circular waves, the reflected waves will be if these are the incident waves, the reflected waves will be the dot ones, will be straight, will be straight. If the source is at F, they will be straight. So you have to master how these waves are reflected. How about if the source